Alright people, this is the quiz, the day 9 quiz on nth roots and fractional exponents. Check your answers. Do you have a pencil in your hand? Get rid of it right now. No pencils. You will learn how to do the problem, but then you will go back and do it yourself. Thank you very much. Let's begin. Well, anything to the 0 power is 1. However, please understand that this 0 power only pertains to the x and y, which are in parentheses here, not the 17. So this kind of goes away, but the 17 is still there. So the answer to number 1 should have been 17. Number 2. Okay, we've got negative 5 to the third power. Well, 5 to the third power is 125. So negative 5 to the third power will be negative 125. Alright, remember, if you raise a negative number to an odd power, it stays negative. If it were an even power, like 4 or 2, it would turn positive. Anyway, for the variables, I multiply. So 3 times 3 is 9. So this will be a to the 9th power and b to the 3rd power. That's it for number 2. Okay, so what's that? Negative 125, a to the 9th power, b to the 3rd power. Okay, number 3. Okay, a power raised to a power you multiply. So that is going to give me x to the negative 12th power. Now down here I have to do actually 5 to the 4th power. 5 to the 4th power is 625. In the past I have often said to you, well, you can just leave it as 5 to the 4th power. But that's when we didn't have a table. If you have a table, you have to go ahead and write 625. Anyway, also I have x to the 4th power. Alright, now what about these x's? Well, by now you have learned that anything with a negative power is on the wrong side of the fraction. So this is going to have to drop down. So let's see. So here are the things that are not moving. 625, that stays right where it is. X to the 4th power, that stays right where it is. Now this moves down, so I will have x to the 12th power now in the bottom. Since there's nothing left in the top, I'm going to have to put a 1 up there. Don't forget that 1. Very important. And then I'll just collect these together. So that's going to give me 1 over 625 x to the, add the exponents, 16 power. And that should be your final answer for number 3. Alright, let us take a close look at number 4. Well, it looks like we have some multiplying to do. 4 times negative 6 is in fact negative 24. What else? As we multiply these variables, we will add the exponent. So this will be a to the 2nd power and b to the negative 2 power. I'm just adding these up. Now, anything with a negative exponent is going to move to the other side of the invisible fraction line, like this. Notice that 24 is not going to move because it is not an exponent. So that is going to give me a final answer of negative 24 a squared over b squared. And that is it for number 4. Okay, how about number 5? We've got the cube root of 256. Now let's see, are we lucky enough that the 256 is on the cube list? No, we are not that lucky. All right, so we need to find something, the biggest number possible that divides into 256. Okay, 125 is not going to work. How about 64? Let's see. All right, let's see, 256 divided by 64. Oh, wow, that works right away. So that means 64 times 4 is 256. Okay, so let's do that then. 64 times 4. So we're going to split things up a little bit. Cube root. All right, 64 is a perfect cube. So let's put that in pink. So 64 times 4. All right, I turned the 64 to a color pink to remind me to simplify it later because it's on the cube list. Now, x to the 6th power is ready to go the way it is, because for variables you just need the exponent to be divisible by the root. 6 is divisible by 3. So everything here in pink is going to simplify and come outside the radical. So cube root 64 is 4. So the 64 simplifies to 4. For the variable we just divide, so this will be x squared. 6 divided by 3 is 2. So that's it for the pink stuff. Now for the blue stuff, it's really just the one number here. I've got the cube root of 4. So that is the final answer. Notice I can't go any further, even though that's a 4, because this is not a square root, this is a cube root. And 4 is not on the list. Okay, let's take a look at number 6. That 3 is just going to sit there. It's not going anywhere. Now we got the 5th root of 300,000 and 8 to the 7th power. Now 5th root, I see 100,000, not 300,000, but it should be pretty easy to split this up. Okay, so we're doing 5th root. Obviously 300,000 is going to be 100,000 times 3. So we will go ahead and put our 100,000 in pink because that is on the list and it will reduce. So we will break up, we will factor 300,000 as 100,000 times 3. Similarly, a to the 7th power. We need something divisible by 5. 7 is not. So we will have to split it up as a to the 5th power, which is divisible by 5, with 2 a's left over. All right, together they still make 7. Now everything here in pink will reduce and come out of the radical. So the 5th root of 100,000, 5th root of 100,000 is 10. So that's going to become 10. Now with a to the 5th, I just wind up dividing by 5, the exponent. So 5 divided by 5 is 1, so that just leaves a. So that's it for the pink stuff. Now everything in blue is going to be left just the way it is. So I will still have the 5th root of 3a squared. And I will also have this 3 from the very front. I will just multiply these together and that'll be it. So I will have 30a and then the 5th root of 3a squared. So that should be the final answer for number 6. All right. We've got negative 5b to the 3rd power. We've got the cube root of some stuff. Hold on, let me see now. Cube root 512, it's on the list. So that's good. That makes our job easier. So we have the cube root you saw that 512 is on the cube list, so I will write it in pink. It's okay to take the cube root of a negative number. The result will simply be a negative number. Let's see. 8 is not divisible by 3, so I will have to split this up as b to the 6th power, which is the first number below 8 that is divisible by 3. And I will have 2 b's left over for a total of 8 still. Now everything here in pink is going to simplify and come out of the radical. So the cube root of 512 is 8. So the cube root of negative 512 is negative 8. Alright, for the variable you're just dividing, so that's going to be b squared. So that's it for the pink stuff. Everything in blue is going to stay like it is, so cube root of b squared. Now this out here is still there, and please understand that we are multiplying. Alright, we are multiplying. So negative 5 times negative 8 is positive 40. B to the third times b squared is b to the 5th power. And then I will still have this, cube root of b squared. So this is the final answer for number 7. Booyah! Oh, number 8. Fourth root, 160 and stuff. Well, let's get on and break it down, my friends. Let's break it down. Now, 160 is not on the 4th power list. But I see 16, and I see 16 kind of right here. So that tells me that what we have here is 16 times 10. All right, we don't need a calculator for that. 160 is 16 times 10. And 16 is on the 4th power list. So I'll make it in pink. Now, as far as the variables go, I need exponents that divide by 4. So how about x to the 8th power, the first number below 10 that divides by 4. If I do x to the 8th power, that's going to leave 2 x's left over. Now y to the 3rd power is already less than 4, so there's nothing I can do with it. So that's just going to stay under the radical no matter what. So now everything shown here in pink is going to simplify and come out. 4th root of 16 is 2. Now with the variable I just divide. 8 divided by 4 is 2. So that's x squared. Okay. And then that's it for the pink stuff. Everything shown here in blue is going to stay the way it is. 10 x squared y to the 3rd power. And that is the final answer for number 8. Okay, how about number 9? Now, since the roots are the same, both root 4, I can do this division. So I'm going to do that. What I'm saying is this. For example, 2 goes into itself once, and 2 goes into 32 16 times. Okay, so I'm doing this division. Bam, bam. So what's going to happen is down here, as I divide these things, instead of a 32, now I have a 16. Now how about the x's? This x is going to cancel out one of these x's, and that's going to leave me with x to the 9th power instead of 10. These 3 y's are going to cancel out 3 of these y's, and that's going to leave y to the 14th power. Alright, now everything up here is canceling out, so I'm just going to put a 1 up here to hold that place. So this is what I have so far. Now I'm going to see what I can simplify and what needs to be split apart. Fourth root, huh? Now 16, right there on the list. 16 is a fourth power. So I'm just going to write that in pink. It is ready to go. 9 is not divisible by 4. So I'll have to split this up as x to the 8th power with one extra x left over to make 9. 14 is not divisible by 4. So I will have to split this y up as, let's see, y to the 12th power. 12 is the first number below 14 that you can divide evenly by 4. And see, how many leftover y's do I have? Okay, 2 extra y's will make the 14. Now everything in pink here is going to simplify and come out of the radical. Please do not forget that this entire thing is in the denominator, so we need that 1 up there. See, the fourth root of 16 is 2. So I'm going to have 2 from that 16. For the variable, I just take 8 divided by 4. So that is x squared. And for the y here, I do 12 divided by 4. So that is y to the 3rd power. Now everything in blue is going to stay just like it is. So that means I'm going to have the fourth root of x y squared. Okay, and this is your final answer for number 9. Okay, number 10. These are both square roots, so I can go ahead and multiply these together. So I'm going to do that. 2 times 25 is 50. X times x to the 4th power is x to the 5th. Y times y to the 3rd power is y to the 4th power. And then I've got z. Okay. Now I'm going to break stuff up and simplify what I can. 50. Alright, please understand that there's an invisible 2 right here. This is the square root. You don't write the 2, but you imagine it. 50 is not on the n squared column. It's not there. But 25 is. And so I see that I can split up 50 as 25 times 2. So we should do that. 25 times 2. I'm going to go ahead and write the 25 in pink to remind me that I can take the square root of 25 later. Now, as far as the variables go, I just need the exponent to be divisible by 2 because of this. 5 is not divisible by 2. So I will split up x to the 5th power as x to the 4th power, which is the biggest number under 5 that is divisible by 2. And it's going to have one x left over because I need a total of 5 still. Y to the 4th power. 4 is divisible by 2. So y to the 4th power, I'm just going to keep it the way it is and make it pink. Now that's z, my friends. Z, just one lonely z. There's nothing I can do with that. It's just going to have to stay blue. So everything shown here in pink is going to simplify and come out front of the radical. So the square root of 25 is 5. Okay, the square root of x to the 4th is x squared because 4 divided by 2 is 2. For the same reason, the square root of y to the 4th is y squared, 4 divided by 2. So that is it for the pink stuff. Now everything in blue is going to be trapped underneath. I'm talking about your 2, your x, and your z. So this is the final answer. Please don't put a 2 right here. Minus 1 if you do that. Okay. There is your final answer for number 10. Alright, you see all these roots? They're all 3's. Because the roots are all the same, you can go ahead and do this multiplication and division. I say we start by putting the numerator into one radical. So if we do that, we will have the cube root of, let's see, 4 times 8 is 32. X times x to the 4th power is x to the 5th power. Y times y to the 4th power is y to the 5th power. Okay, fine. So I put those all together. So far in the denominator, I still have the cube root of 4xy squared. Now again, since they're both cube root, I can do this division. Alright, so let's see what happens. Cube root still. 32 divided by 4 is 8. X to the 5th divided by x is x to the 4th power. This x is canceling out one of those x's. Y to the 5th divided by y squared is y to the 3rd power. These two y's are going to cancel 2 of these. Leaves 3. So now there's no more fraction. Everything in the bottom canceled out. But I can simplify this a little bit more. So I'm going to break things down as needed. Now as far as the 8, I like the 8. Why do I like the 8, you say? Because I'm supposed to be looking for cube roots because of the 3. And 8 is right here on the list. So I made it pink. 4 has to be divisible by 3, and it's not. So I'm going to have to split this up as x to the 3rd power with 1 extra x like that. Now y to the 3rd power is good just the way it is because 3 is divisible by 3. So look, everything shown in pink is going to simplify and come out. The cube root of 8 is 2. Alright, dividing by 3 I just get x, and same thing here, I just get y. So that's it for the pink stuff. Alright, now really that just leaves one lonely little thing under here. That's the cube root of x, like that. So that is the final answer for number 11. Number 12. When you multiply, you add the exponents. So this is going to be a relatively straightforward adding of the exponents. So we're just going to do 1/2 plus 1/3. I like to do this off to the side. So let's see, 1/2 plus 1/3. When you're adding, this is when you need like denominators. So we will multiply these by 3's and multiply these by 2's. So that is going to give us 3 over 6 plus 2 over 6. 3 plus 2 is 5 over 6. Okay, so that is going to give us x to the 5 over 6 power. And that's it. Since it is the original problem was in exponent form, I'm going to leave my answer here in exponent form. Brilliant. Number 13. One thing to keep in mind about this negative sign. When I do the power, the negative sign is not included. Alright? When you apply an exponent to a number, the exponent only pertains to the number. For example, if I had -3 squared, the result of this would be -9. Unless I put parentheses around the negative sign, the squaring happens first. The squaring only pertains to the 3, not the negative. So I'd square this, I'd get 9, and then I'd stick the negative on. It's the same thing here. This negative sign is going to sit there way out front. In fact, I'm purposefully drawing it far to the left. And so I'm going to evaluate this part separately, and then whatever I get, I will just stick the negative sign on it. Best thing to do is to rewrite this in radical form. Remember that this is the power, you know, the exponent, and this is the root. So third root. So that means I'm going to be doing this. The third root of 8, and then all of that raised to the 5th power. So if I take the cube root of 8, cube root of 8 is 2, as you can see on the chart. So I will get 2 inside of here. And then I still have it to the 5th power. That negative sign is still there. It's not involved in this process, just sitting way out front as we do the power to the 8. Now 2 to the 5th power, 2 to the 5th power is 32. So this will become 32. And again, that minus sign that's been sitting there this entire time will just get stuck on the front. Nothing happens to it at all. So that is the final answer for number 13. Alright, number 14. There are a couple of different ways to think about this, but my favorite way is to recognize a negative exponent when I see it. Alright, now, and please understand, because this is sort of a diagonal looking exponent, I'm reading this as 64 to the negative 2/3 power. Okay, I'm not treating it like a negative 2 and a 3. I mean, which would be the same thing, but it's a negative 2/3. And thus, because I have a negative exponent, everybody knows that when you have a negative exponent, you are on the wrong side of the invisible fraction. So if I drop this entire thing down, okay, what I will have it then is 64 to the positive 2/3 power in the denominator. I will then need a 1 to sort of hold the place. So I'm going to evaluate 64 to the 2/3 power, but whatever I get, I'm going to always remember that it is in the denominator of this fraction. So rewriting using radicals, I'm going to have 1 over, like I said, again, this 3 is the root. Alright, cube root. This 2 is the power, second power. So the cube root of 64 is what I write first. Cube root of 64. And then I will do that to the second power because of the 2. Now the cube root of 64 is 4. So that is going to give me 1 over 4 to the second power. But then next thing you know, I'm going to have 1 over 16 because 4 squared is 16. So this should be my final answer, 1 over 16. Now here's another way to think about it. I could treat this as a negative 2 power. Right? I'm still going to consider this negative 2 as the power and this 3 as the root, so like I was doing before. But instead of dropping the whole thing down to the bottom, if I look at it as a negative 2 over a positive 3, then when I convert this into radical form, I could think of it this way. Alright, the cube root, alright, I could think of that as a positive 3. So cube root of 64. And then, if I think of this as a negative 2 all by itself, then I could think of it as doing a negative 2 power. Still, the cube root of 64 we found was 4. So that would give me 4 to the negative 2 power. So now I still have to recognize that having a negative exponent means drop it down to the bottom of the invisible fraction. So I'm still going to wind up with the same thing. I'm still going to end up with 1 over 4 squared, which is still going to be 1 over 16. It's just a slightly different way of thinking about it. Okay, here comes the last problem of this lesson. Number 15. Alright, now once again, I see these negative exponents. So if I were you, I would definitely look at it this way. Anything with a negative exponent, like for example this and this, anything with a negative exponent is on the wrong side of the fraction. So this y expression is going to have to come down, and this x expression is going to have to go up. So watch this. I like to first write down the things that are not moving. So that x right there, it's not going anywhere. This y to the 3rd power is just going to sit right where it is, like a rock. Now, let me switch to pink to highlight the things that are in motion. Now this y to the negative 1/2 power is going to come down as y to the positive 1/2 power. This x to the negative 3/4 power is going to go up and become x to the positive 3/4 power. Now I don't have those pesky negative signs which cause students to make so many mistakes. Now, as I put these x's together, I will think of this as x to the 1 power to help me add. So you know when you multiply variables together, you add their exponents when they're like bases. So what's really going to be happening in my next step, in the numerator, I'm going to be doing x to the 1 plus 3/4 power. In the denominator, I'm going to be doing y to the 1/2 plus 3 power. So I just need to do this sum, and then I'll be finished. Okay, so I'm going to do that calculation off to the side. So 1 plus 3/4. I'll do that right here. So if I want to do 1 plus 3/4, one way to do that is I need like denominator. So this is like 1 over 1, which is the same thing as 4 over 4. I did that to get the denominators of 4. So this is 3/4. I mean, you know, hey, if you want to, you can think of it as multiplying everything by 4. And so I get 4 over 4. Whatever makes you happy. But then 4 plus 3 is 7. So that is 7 over 4. Okay, so that's what I get if I do 1 plus 3/4. So far that means in the numerator I have x to the 7 over 4 power. Now I need to do the same thing with the y's down here. Purple. Indeed. I will do 1/2 now plus 3. Now this is like 3 over 1, yes? So I need like denominators, and I can get that just by multiplying by 2. So that is going to make, alright, so I've got 1/2 plus 6 over 2. 1 plus 6 is 7, so that would be 7 over 2. Okay, so I had 7 over 4, now I have 7 over 2. And that is going to give me the final answer. So I will have y to the 7 over 2 power. And I would just leave it just like this. Alright, I hope this video... Whoa! I thought I was done. I thought I was done, man. I was putting my closing statement. Still got 2 more problems. Okay. Looks like we have a couple of bonus problems. Yay. Alrighty then. We have to do this thing to the 3/5 power. Clearly, this is a job for radical form. Notice this negative sign is inside the parentheses, so it will be included in the middle of the problem. This 3 is the power, as in third power. And this 5 is the root, as in the 5th root. So I'm going to have to do the 5th root, like I said, of negative 1024. And then all of that will have to be raised to the 3rd power, like so. Let's see if this number is a perfect 5th power by looking in this column. Oh, look, it's right there. What about the negative, though? Is this going to be I or not possible because it's negative or something like that? No. We will not be dealing with I in this unit. So simply what is happening is if this had been even, like 4 or 6, we would just put not possible. But since it's odd, you can take the root of if you can take an odd root of a negative number, it's simply a negative answer. Nothing magical, nothing really special. So if the 5th root of 1024 is 4, then the 5th root of negative 1024 will simply be negative 4. No big deal. So that means I'm going to have a negative 4 inside of there, 5th root of that guy. Now I have the negative 4 to the 3rd power. Now here again, because it's an odd power, it's just the negative is just going to stay negative. If this were an even power like squared or 4th power or 6th power, it would turn positive. But it's odd, so I'm going to have a negative whatever. So negative 4 to the 3rd power. Okay, negative 4 to the 3rd power. Well, look, a positive 4, maybe I should get rid of these negative signs again for a second. Positive 4 to the 3rd power is 64. So guess what? Negative 4 to the 3rd power will simply be negative 64. And there you go. That is the final answer for number 16. Alright, number 17 really and truly is the last problem on this quiz, and thus this lesson. Okay, I need to do everything inside of here to the 1/3 power. Now if I were you, I would temporarily just write 512 to the 1/3 power, like that. Now with the variables, when you do a power raised to a power, you multiply. So this is going to be x to the. Now 15 times 1/3. Let me just highlight this off to the side here. 15 times 1/3. Please understand that 15 is like 15 over 1. So it's 15 times 1 is 15. 1 times 3 is 3. But then that reduces down to 5. 15 divided by 3 is 5. So this is just going to be 5. Right here, okay? Now, similarly, the y's I have to multiply, but 1 times 1 is 1, 4 times 3 is 12, so that'll just be y to the 1/12 power. Again, I multiplied. So this is almost the answer. I just need to deal with this guy right here. Okay, what is 512 to the 1/3 power? Well, look guys, just understand that this is the cube root. 1/3 power is the same thing as the cube root of 512. going to bring this stuff down. And the cube root of 512 is 8. So that's going to give us 8 x to the 5th power y to the 1/12th power. So that, my friends, should be the final answer to the final problem. Alright guys, make sure that you can do all of these problems on your own. I'm always telling you not to watch these videos with a pencil in your hand. Some of you guys, Aaron, tend to ignore me when I give you that advice. But then the results are bad when the quiz or test comes out. So please, the key is copying off of me just gives you a false sense of understanding what you're doing. You always feel smart when you're copying off of me, but you don't really know if you know it or not until you go back, preferably like an hour later, and try to do all these problems again by yourself. If you can do them by yourself, after a period of time has gone by, then there's no way you're going to come in and fail the quiz. Fact. I will see you on the next video.